In this session, we discussed various data types in JavaScript, why JavaScript is called as a dynamically typed language, what is mutable and what is immutable. Everything is explained with real-world examples. I'm sure it's worth watching till the end. Hi all, welcome to the complete JavaScript beginners tutorial by CodAffection. First of all, let me start with a normal variable declaration pattern in JavaScript. In previous session, we have already discussed the keywords let, wo and const. As we have discussed, the variable declaration must start with any of these keywords and then followed by a variable name. If we want to initialize the variable, we can pass the value here. To verify this pattern, let's declare a few variables here. So I have created the variable name with the keyword let and it is initialized with this value ben. Now let me create one more variable here. Let me introduce you a new term, literals. Literals are the fixed or hard-coded values in our programs. Fixed values that we provide for initializing a variable is definitely a literal. So instead of the term value here, the right term would be literal. Fixed values outside a declaration statement is also a literal. Along with this pattern, I would also like to show you how to create multiple variables in a single statement. Actually, I should have shown this in previous session. Unfortunately, I forgot it. So it goes like this. First of all, we can use any of the keywords for let or const. And then we can have the first variable and let's initialize that with some random value. And then put a comma before the next variable. And let's initialize that. Then put a comma and then the third variable and so on. So this is how we can create multiple variables in a single statement. Here in this statement, only one type of keyword is allowed, either var or const or let. Now back to our topic, data types in JavaScript. Basically, data is information. It could be related to anything. We collect data through our application interface and we will store it somewhere in database. Finally, we will show the data in visual representations through graphs and maps. Application will process the data for better conclusion and analysis as per the application requirement. So that's the brief life cycle of data. In software development, data is everything. It's the fuel for an application, where the application or software is like an engine. Definitely you will understand it gradually in your software development career. Now, the primary agenda behind this session is to get familiar with different categories or types of data as per the language JavaScript. All programming language will categorize data into different types. There could be few differences in the categorization of data types of one language to other. In JavaScript, there are 8 data types: Boolean, Null, Undefined, Number, BigInt, String, Symbol, and Object. I will be explaining these types in a different order than from the listed order here. So, the first data type, Boolean. It only contains 2 values, true and false. These values are used to indicate the logic yes or no. For example, let me create a new variable here is adult. Like the variable name implies, this variable is used to indicate whether a given person is an adult or not. Now, if I assign the variable with the Boolean value true, now this variable initialized with this Boolean value true indicates this person is an adult. Now, if I replace this true with false, we assign this Boolean value false to this variable when the person is below the age 18. Means he or she is not an adult. So Boolean values can be used when there is only 2 possibilities, like whether active or not, whether logged in or not, etc. Now let's talk about the data type number. It represents numeric data including integers and floating point numbers. To make things more easier, think about number line that we learned in our elementary school. At the center we have 0, on to the right side all the positive numbers 1, 2, 3 and so on. On the other end we have corresponding negative numbers -1, -2, etc. In between these integers we have values with fractions like 1.5, 2.3, etc. Same on the negative side also. So these numbers that we can represent on this number line comes under the type number. For example, I will create a variable age and let's initialize that with an integer. So currently this age is having the data type number because we have initialized that with this integer 45. Floating point numbers is also comes under the data type number. For example, Let's create a variable amount and let's initialize that with this floating point number 4.5. So currently this variable amount is also having the data type number. Now, there are some limitations to the values that a number type can represent. The range of values that a number type can safely represent is in this range. The maximum value is 2 to the power 53 minus 1. Same on the negative side also, which is equal to these numbers here. You can check these max and min values through JavaScript code itself. For that, we can use this JavaScript standard object number. We'll be discussing what is an object in JavaScript in a bit. For now, you could assume it as a collection of variables. Okay, so this object number represents the number type. So this object is available in global scope. Inside this object, we have different values or functions regarding this type, data type number. To see the max safe value that a number type can store, we can access this value here, max safe integer, from this object number. Now let's print that into the console window. So console.log, inside that we can pass this value. So here we have the max safe value. Now to see the min safe value, we could do this. Okay, if we store a value outside this range, then it would be rounded to nearest number, or in other words, JavaScript doesn't guarantee the same number while retrieving it back. We may lose the precision. Let's check that here. So first of all, I will save this max safe integer into this variable amount. Instead of min, we have to pass max safe integer. So this is the maximum safe value that we can store within the number type. Now let's print this variable amount. So here we have the exact value printed in the developer console. Now let me copy this and let's assign the same directly to this variable amount. Now it prints the same value as that we have passed here. Now let's assign a higher value here. It works fine. Let's increment this by 1. Boom. See, the precision is lost here. See, these two numbers are different. Okay, so that's what we meant by round error. So that's what happens when we save a value outside the safe range into a number type. While trying the same on your system, so don't expect to see the same error for the same number. You might be having the round error for a different number. It will be different to different web browser and system. Sometimes the value outside the safe range may work as it should. For some values, it may not work. Same in the case of min safe value also. If we go beyond the min safe value, same will happen. Now, how far this number type allows to store the values outside the safe range. So these are the ultimate max and min value a number type can store even after rounding. It's not safe to store value outside the safe range, even though it's possible up to this max and min values here. We might be losing the precision in this unsafe range. If we store a value greater than that, it will be treated as infinity. So plus infinity on positive side and negative infinity on the other end. Infinity is a constant to indicate the number is insanely huge that the type can't represent it. So these values plus infinity and minus infinity also comes under number type. Now what should we do if we want to store a value outside the safe range here? For that, we have the data type BigInt. We can discuss that in a bit. Before that, let me show you a few operations that you can work with number type, starting with addition, subtraction, multiplication, division, etc. So here we have the value age and it is initialized with the value 45. So we can use this operator plus. So the operators for basic math operations is same as that of mathematical operators. Let's add 5 into it. So here we have the result 50. Like this, we could do any math operation, subtraction, multiplication, division, etc. In mathematics, we all learned that any number divided by 0 is infinity. So we could see the same infinity in this case also. So this is the plus infinity. If this number is negative, then it will be negative infinity. See? Now if we perform an invalid operation on this number type, it will end up in a new value. Let me try to multiply the value with a name, John. See, here we have a new value, NaN. It means not a number. So this value NaN is also comes under the data type number. So whenever you see this value in your program output, just understand this. There is some invalid operation performed on number type. And keep in mind that JavaScript is case sensitive. So the case of this NaN and infinity must be as it is. Then only it will have these meanings that we have described here. Now let's talk about the data type BigInt. To store integer numbers greater than the value that a number type can safely represent, we use BigInt type. BigInt can store arbitrarily large numbers. With this type, we can only store integers, not floating point numbers. There is no limit specified for it, but it can have any big number as long as the memory space is available. Now let me show you how to assign a BigInt number to a JavaScript variable. So here we have the variable some big number. Now to assign a BigInt number to this variable, first of all we have to type the number. After that we can append n to indicate this number is belong to the data type BigInt. So this is one way of assigning BigInt data type into a variable. Now let's print this value to the developer console. So while printing the value also we are seeing the letter n at the end. Now there is one more way to assign a BigInt number to a variable. For that, we can use this function BigInt. Inside this function, we can pass the value. Here we have reassigned the variable with another BigInt number. Now that's what we are seeing inside this developer console. At the end, we can see this letter n indicating this is also a BigInt number. To store a value within this BigInt type, it's not necessary to have an insanely big number. We can store small numbers in BigInt type too. But for numbers within the safe range here, it's better to use the number type. If we are dealing with insanely large values like scientific measures, then we can use BigInt type. For example, number of stars in the universe or number of atoms per molecule, etc. So I hope you got the idea. Now, most of you might be having this question: if BigInt type can store values outside this safe range, why number type would store values in this unsafe range? To understand this, first therefore we need to know how JavaScript stores number type. JavaScript uses IEEE 754 double precision 64-bit floating point representation. If these technical terms bothers you, just understand this. To store a number type value, JavaScript uses 64 bits in binary representation, and all numbers are stored as floating point numbers, even an integer. Even if we store the value 5, it will be saved as corresponding floating point number 5.0. As per this representation, these are the safest max and min value that can be represented within this floating point representation. If the number goes beyond this range, then the number will be rounded as per the rules or instructions in the IEEE 754 representation. Definitely, we don't want to dig deep into the particular floating point representation. It's too mathematical. So in short, the particular floating point representation does the rounding, and for the numbers outside this range, you could expect rounding error, or in other words, the number loses its precision. Data type BigInt is added to JavaScript in the year 2020. With it, we could store any big integer as long as the memory space is available. Now, that's all about JavaScript numeric data types, number, and BigInt. Now, before covering rest of the data types, let's discuss why JavaScript is called as dynamically typed language. I have mentioned this terminology while defining what is a JavaScript. In some languages like Java, C, C++, C#, we have to explicitly mention the type of a variable while declaring it. Such type of languages are called as strongly typed language. For example, if you want to declare an integer variable, we have to declare it with this keyword int, meaning this variable is of the type integer. If we want to declare a variable to store floating point numbers, we have to specify the keyword float while creating the variable. In rest of the program, we are not allowed to assign a value outside the type of the variable, meaning we can't assign floating point number to an integer variable. That's not the case with JavaScript. We don't have to specify the type of a variable while declaring it. Instead, we are using any of these keywords let, var, or const. For the same reason, JavaScript is called as loosely typed language, because type of a variable is not specified while creating a variable. We could assign value from any data type. So here the variable a is created and it is initialized with this number data type. Then I have reassigned that with a Boolean value false. So in JavaScript, a variable can have different data types at various stages of the application. Languages with these behaviors determines data type of a variable based on the assigned value at runtime. So a single variable can have different data types, hence JavaScript is also known as dynamically typed language. Since type of a variable is dynamic in accordance to the value assigned to it, in JavaScript we have a special operator typeof to check the type of a variable in between the program. For example, I want to check the type of the variable a in this line here. For that, we could do this type of, then a space, after that we can provide the variable name here. So at this line the type of this variable a is number. See, now let me copy this and pasting that after this Boolean assignment here. Here the type of the variable a is Boolean. So for a same variable in JavaScript it can have different data types. So that's what we meant by dynamically typed language. And keep this in mind, this operator typeof can be used to find data type of a variable at various stages of the program. Now let's talk about the data type string. It represents sequence of characters. They are declared through quotations. For example, let me declare a variable name and I will initialize that with this name Fiona Green. So currently this variable name is having the data type string. To assign a string value, we can either use single quotes or double quotes. In between them, we can throw any character. So let me create one more variable address. So the string must start with either of the quotes. Inside them, we can pass the address like this. So this is also a string. So I hope you understood what is meant by string. We have a lot to talk about JavaScript strings. We will do that in a separate section after discussing operators in JavaScript. Now let's talk about both these types, undefined and null. Actually, both are two values in JavaScript. Undefined indicates the variable is created but not initialized yet. We have seen this undefined in previous session while talking about hoisting. Now, null indicates non-existence of something, or you could say absence of a value. For example, here I have defined this variable name but not initialized yet. Now if you try to log this variable here, we could see the value undefined because we have only created the variable not initialized. See, here we have the value undefined, means the variable is created but not yet initialized. Now to give a proper example for null variable would be difficult. Let me try that. Now assume that you are dealing with a human resource management software or HR software, and inside the application we have a variable team lead ID. So inside the application, for every employee there will be a unique ID for each employee, and inside this variable for a given person we have to store the corresponding employee team lead ID. Now assume that the person or employee is a manager or a head of a department. Then for that person there won't be a team lead. Then this value or data type null is more appropriate to indicate this situation. This toilet paper picture illustrates these concepts perfectly. If you are confused, don't worry, you will understand once you encounter them in your programs. Now let's talk about the data type objects. For now, I would say it's a collection of key value pair wrapped within a pair of curly brackets. Before saying anything, let me show you an example here. So here we have the variable student. Into it, I would like to store an object. So the object must be wrapped or enclosed within a pair of curly brackets like this. Now inside this we can provide all the information about this student through key value collection like this. So here we have the admission number, and then we can provide the name also, then age, etc. It goes like this. So this is an example for an object. It often resembles a real-world entity, like all the information about an entity is grouped or structured into one thing. We will dig deep into JavaScript objects later. For now, just have the basic idea about them. So this is a key, this is another key. Into them we have assigned the values here. So totally a key value collection. These keys in an object is called as properties. Let's look how to retrieve and modify values inside these keys or properties. To retrieve a value from this object, we could do this. First of all, the object name, which is student, then a dot or period symbol followed by the key or property name. So from now onwards, these keys will be called as properties. So now we are going to access the property name here. See, here we have the output. So this is how we can retrieve a value or a property from an object. If you want to change this value, you could do this student dot name. Let's assign that with another value. Here we have the updated name. So this is how we can work with objects in JavaScript. Now, data types other than objects are collectively known as primitive data types because they are their own, not derived or made up of other types of data. That's not the case with objects. We are storing numbers and strings in JavaScript object properties. Now, let's look how an object is stored in the memory. Objects are stored somewhere in memory, and the variable used to declare the object stores the reference or address to the stored memory location. And for the same reason, objects are also called as reference type. That's not the case with primitive data types. The actual value is saved in the corresponding variables. Now let me actually demonstrate it with few examples here. Here we have the object student. Let's rename it with student1. Now let me create another variable student2 and let's assign student1 to it. Here this is what happens. The object is saved somewhere in the memory. Say the memory location address is 1000. So the variable student1 is having the reference 1000. So that reference 1000 is assigned to this variable student2. Here the reference to this object is passed, not the object as it is. As a result of that, when we make an update or change in a property through one variable, the same change reflected while accessing with other variable also, because the actual object is saved once and the same reference is used or passed to two variables student1 and student2. Let me show you that here. First of all, I will print the age of this student. So student2.age, currently it is 24. Now before this log statement here, I will update the age with this student1 variable. So student1.age is equal to 20. The age is also updated inside this object student2 also, because both of these variables student1 and student2 referring same object or same location where this object is saved. So whenever we are making changes like this, and the same change is retrieved with this variable student2. So that's the behavior you could expect from a reference type. That's not the case with a primitive type. For example, let me declare a variable score1 and let's initialize that with 50. Let's create one more variable score2 and let's assign score1 to it. Here this variable is having the data type number, which is of the type primitive. So when we assign score1 to score2, it is actually passing this value itself, not the reference to this variable. So that's the difference between reference type and primitive type. Now let's remove these second variables here. Now with this assignment statement here, we are able to change a value of a single property from this object age from 24 to 20. This is only possible with the data type objects. We can modify a part of an object without modifying rest of the properties or redeclaring the entire object. So they are called as mutable, means they can be changed. That's not the case with primitive data types. We can't modify a primitive value. Can we make modifications within this 50 like we have done within this object here? It's not logical or not possible. So that's why primitive types are called as immutable. Of course, we can change the value inside this variable here to something 40 or 30 like that, but we can't make modifications within these values 50 or 40 like we do in this objects here. Here we are actually redeclaring a new variable 40 to initialize this variable score1. So primitive types are immutable, means they can't be changed, but objects can be changed, so they are called as mutable. Now finally we have the data type simples. This is also a primitive data type. It's a special data type. Its value is unique so that it can't be recreated. I know you are confused. Let's try a few examples here. I will create a variable symbol1. To create a symbol, we can only use this function here, simple. Okay, so this function will return a symbol that we have stored into this variable symbol1. Now let me duplicate this line here. Let's rename this variable as symbol2. In this second line of assignment here, we are calling this simple function exactly same as we have done for the first simple here, even though these simples won't match each other. So that's what makes this data type special. How can we compare two variables in JavaScript? For that we have this operator, strict comparison operator. The operator looks like this. 3 equality simples. If you want to compare two values, you could do this. Let's try that with some integers to check whether 4 is equal to 4. You could do this. If they are equal, it will print the Boolean value true. If they are not equal, it will print the value false. We'll be discussing more about these types of operators in next few sessions. For now, let's compare these two variables or simples. So first of all, we have simple1. Let's compare it with simple2. See, they are not equal even though we are using same function as it is for declaring both of these variables. So this is what we meant by simples. They return always a unique value and we can't recreate it. While creating a simple inside this function, we can pass a title or description like this. It will be helpful to identify these simples during testing or debugging. So these descriptions or title has nothing to do with the value of these simples, because even if you pass same title or description inside these functions, still they won't match each other. Still, this comparison shows this value false, meaning these simples are not equal. Don't need to think much about simples, just think they always return a unique value when we call the function simple. This data type is introduced in the version ES6 because there are few requirements in JavaScript that was not possible or difficult without simples. I would like to discuss those special cases or requirements here, but it would be better if we postpone that discussion for future sessions after learning required prerequisite topics. Meanwhile, don't worry, simples are rarely used in JavaScript programs, so please wait for the discussion where we will dig deep into simples data type. That's all for now. You could find the JavaScript notes for this tutorial in our JavaScript note-taking project. GitHub repository is given in video description. In next session, we'll be discussing operators in JavaScript. Please consider subscribing to this channel CodAffection if you are not a subscriber already. Please thumbs up and share this video with your friends and colleagues. See you in next session.